Hello friends, let's start with the module 3 of optimization technique. So in this module we will be studying about local and global optima, convex sets and function separation with hyperplane, application of Hessian matrix in optimization using gradient descent, sequential search, 3-point search, and in this sequential search only it's a second part is Fibonacci search. Okay, so first let's start with the local and global optima. What is global extrema? The global maxima or minima of a function is global extrema. Local extrema, the local maxima or minima of a function is considered as local extrema. Okay, so local extrema, when it appears in the question, you have to find local maxima and minima, and when global extrema will come, you have to find global maxima and minima. Okay, so local maxima or minima is the maximum or minimum value in a given interval. So see, local maxima. What is local maxima? Local maxima is a maximum point in a particular interval, and local minima is the minimum point in a particular interval. Okay, so just see this. F of a is greater than equal to f of a minus h, and f of a is greater than equal to f of a plus h. That is, in a particular interval, f of a minus h, f of a is greater than or equal, and similarly, in an interval a plus h, f of a is greater than equal. So it is the maximum point. Okay, same you have to apply here also. F of a is less than equal to f of a minus h. That is what? The left side of the particular interval, and then this is the right side of the particular interval, which is f of a is less than equal to f of a plus h. Okay, so let's see it visually. So this point 1, 3, 5 is local maxima because it's the maximum point in an interval. So interval is 2 and this left side of 1, so it is maximum, so it's the local maxima. 3 is also the maximum point in interval 2 to 5 or 4, so it's a local maxima. Okay, so 5 in the interval this and this, so it's a local maximum. Similarly, local minima you can see 2, 4 and 6, in which 3 is the highest peak, so it is global maxima, and 6 is the lowest step, so it's a global minimum. Okay, so what's the saddle point? Saddle point is a point where the gradient is 0 but it is not a maximum or minimum. Okay, the function curves up in some direction and down in other. Okay, so in saddle point you can't be able to find minimum or maximum values. Okay, so let's see the question. Describe local and global optima. List out the difference between local and global optima. So you just see it and read once, you will be able to understand. I already discussed all these things. Okay, so just read it by yourself. If they see the note, if the derivative of a function changes sign around the critical point, the function is said to have a local extremum at that point. Okay, let's see what's it's written by the question. Analyze local minima and local maxima using first derivative method for the function f of x is equals to 2x cube minus 3x square minus 12x plus 5. Okay, so the function is given, you have to analyze it via the first derivative method. Okay, so let's see. For the first derivative method, you first have to differentiate it. Okay, one time. So differentiation of this is 3x square minus 3x minus 12. Okay, so if you simplify this, you will get x is equals to 2 and x is equals to minus 1. Okay, all the simplification is written in this type here. You just see it. Using first derivative test, we check sign of f dash x around these points to determine minimum and maximum. Now you have to see the neighbor points around this 2 and minus 1, so that to check whether the point is changing the sign or not. Okay, so let's see. Check around x is equals to minus 1 first. So take a point smaller than minus 1 and take a point bigger than this minus 1. Okay, so first take a point smaller than this minus 1 or left side of this minus 1, that is minus 2. So f dash of minus 2, if you put the minus 2 value in this differentiated function, then you will get 24, which is greater than 0 and which is positive. Okay, so let's pick a right side value of this minus 1, that is 0. So f dash 0 is equals to what? Minus 12, which is less than 0. Okay, which is negative. So positive to negative, the sign is changing. Okay, so it's a local maximum. Why? Because it's changing the sign from positive to negative. It is going like positive to negative. It's like see here, it's positive to negative. Okay, so it's local maximum. So this one is local maximum. Okay, I hope you understand. Now let's move to the second. Check around x is equals to 2. Similarly, we have to check around 2. Take a value less than 2 and take a value greater than 2. Okay, less than 2 is 1 and greater than 2 is 3. Check the point where it is changing the sign. For 1 it's minus 12, which is less than 0 or negative. Okay, for x is equals to 3 it's positive, so negative to positive it's going, so it's a local minima. Okay, you can't say whether it's a global because only for 2 points you are checking the things. Okay, so finding function values at x is equals to minus 1 you will get local maximum, and x is equals to 2 you will get local minimum. So you just conclude the answer over here writing the same. Alright, I hope you understand the question. Let's move to the second question. Analyze the local maximum, local minimum of the function f of x is equals to minus x cube plus 6x square minus 12x plus 10 by using second derivative test. Now you have to apply second derivative test. First you have to differentiate one time, then later you have to differentiate it 2 times. Okay, see, first derivative of f of x, this function, it is given as minus 3x square plus 12x minus 12. Okay, so this is first derivation. Making f dash x equals to 0 for critical point. Find the critical point out here. You will get x equals to 2. Now second derivative of f dash x. So f dash x, if you differentiate one more time, you will get as minus 6x plus 12. Okay, now put x equals to 2 over here. You will get f double dash 2 is equals to 0. Now you can see that f double dash of 2 is equals to 0. So you can't be able to get any what? Second derivative is 0. So you can't able to get any critical points because it's 0. So we must use another method. Okay, so that is we were going with the first derivative test only. Okay, so let's go with the first derivative test. We are having x is equals to 2. Pick a point less than this 2 and pick a point greater than this 2. Okay, to check whether the sign is changing or not. Okay, so let's take 1.5. If you take 1.5, it is negative. If you take 2.5, x is equals to 2.5, so it's also negative. So derivative is negative both the left and right of x is equals to 2. Therefore no change in sign at x is equals to 2. So no local maximum or minimum occurs at x is equals to 2. So x is equals to 2, what it is? It is point of inflection, where the point is not changing its sign. Okay, you can also say it's a saddle point. Okay, so let's see the next question. Minimize f of x is equals to 3x1 square plus 4x2 square plus 5x3 square subject to constant is given as x plus x1 plus x2 plus x3 is equals to 10. See, if any question appears like this subject to constraint, then you have to apply this Lagrange multiplier. Okay, what is this Lagrange multiplier? Let's see. Given this is a question, using Lagrange multiplier, Lagrangian form will be given as L x1 x2 x3 lambda is equals to 3x1 square plus 4x2 square plus 5x3 square plus lambda times 10 minus x1 minus x2 minus x3. Okay, why it is? Because x1 plus x2 plus x3 is equals to 10. So bring this 10 to the left side. Okay, so it will become 10 minus x1 minus x2 minus x3. Okay, now find the potential. Now let's find the partial derivative of this and set them to 0. Okay, so partial derivative of this, what you will get with respect to x1, you will get 6.1 minus lambda is equals to 0. That concludes x1 is equals to lambda by 6. Okay, now differentiate it with respect to x2, you will get x2 is equals to lambda by 8. Now partial differentiate L with respect to x3, you will get x3 is equals to lambda by 10. Okay, so putting x1, x2, x3 into constraint, which is given x1 plus x2 is equal plus x3 is equals to 10. So you will get as lambda is equals to 25.5319. Okay, so once you get the value of lambda, you can find the value of x1 because x1 is equals to lambda by 6. So similarly, you find the value of x2, x3 and check for the sum. Okay, if this sum is equals to 10, so it is satisfied. Value is satisfied, that is constraint is satisfied, that is x1 plus x2 plus x3 is equals to 10. So it is satisfied. So now find maximum term value. Maximum term value, how to find? Put all the x1, x2, x3 value over here. Okay, and whatever you will get is the maximum value of function. Okay, I hope you understand this question, and this is important question. So please do see it again. Now moving to the next question, using Hessian matrix, classify the relative extreme for the function. This function is given. Okay, so let's calculate what is Hessian matrix. Hessian matrix can be given as, see here, Hessian matrix can be given as this, H is equals to, for here you will write F11, see, F11, F12, F13, F21, F22, F23, F31, F32, F33. So this is what Hessian matrix. So let's see how to proceed with this question. So first the point function is given, so you have to find the critical point. How to find? By differentiating. Okay, for partial differentiate it with respect to x1, x2, x3, you will find the critical points. Okay, so after finding the critical points, you will get it as x1 is equals to half, x2 is equal. For x2 and x3, you have to substitute. You have to use substitution method, because here both x2 and x3 is present. You can't be able to find by equating it to 0. So you just have to substitute a value from here to there. Okay, so you will get x1 as half, x2 as 2 by 3 and x3 as 4 by 3. Alright, so compute the Hessian matrix now. So now you have to compute the second partial differentiation. Okay, F11 means partial differentiation of this x1 with respect to x1. Okay, so this x1 you again have to partial differentiate it. Okay, so you will get -2 here. Okay, -2, same you have to do for 2, same here you have to do for 3 and 1, 2, 2, 1. All you have to find it as this, and you just have to put it in Hessian matrix, which I have told you what to do. Okay, so the formula I have not written here. For what is Hessian matrix, you should write first and then put all the values over there. Okay, then compute leading principal minus for checking out this relative extreme. Okay, so for checking the relative extreme, you have to compute by leading principal minus. And what is this? You have to check whether order 1, order 2, order 3 is satisfying a particular thing or not. What is that? If all dk, what is dk? This d and k is 1, 2, 3. Okay, so if all dk is greater than 0, you can conclude it as it's the local minimum. And if alternate sign appears with, like, first it is negative, then positive, then negative, then you can conclude it as it's a local maximum. Okay, and otherwise you will call it as saddle point, because if it comes any random pattern, not alternate or anything else, then you can conclude it as saddle point. Okay, so let's see order 1. For order 1, how to calculate dk? K is equals to 1. Okay, so d1 is equals to a11. Okay, so this value you will see, this value. Okay, so d11 is equals to a11 is equals to -2 is less than 0. Okay, it's a negative value, so it's a negative. So let's for the order 2. How to calculate this order 2? Order 2, d2 is equals to, consider only these two, a11, a12, a21, a22. Only these two you have to consider. Okay, only these two. So just put all the values and calculate. You will get a positive value. Okay, so here you are getting as positive. So let's calculate order 3. Order 3 means all the determinant value. Okay, how to calculate all the determinant value? First take -2. First take -2 and multiply this 2 and minus this 2. Okay, you will get the determinant value, because all the this value and this value is 0, so you will get 0 when you take common this 0 or take common this 0, you will get 0. So the determinant value is -2 into -2 minus 1 into 1. So what's that? That is -6. -6 is also negative. So see, as I told you, if you get negative plus negative, negative, positive, negative, so it's what you can conclude, it's a local maximum. So same it is written here. Hessian matrix is negative definite, so you can conclude that the critical points are half, 2 by 3 and 4 by 3 and is a local maximum. Okay, so let's proceed with the next concept. I hope you understood this. So this is also important, you can see. Now let's do the next topic. It's a convex set and separating hyperplane of a convex set. Okay, so what is convex set? You can define convex set as a set C in relation of order n is called a convex set if for any 2 point x, y that belongs to C, the entire line segment joining x, y also lies in C. See with the example. Okay, So this is a circle, these are the 2 points. If you connect these 2 points, then this connection line also lie in the same plane, that is circle. So same is the convex set. Mathematically you can write it as this, and so in we pick any 2 point in the set, every point between them is also inside the set. So every point between this line, between these 2 lines are always in the convex set. Okay, so this is convex set. Some more example is written here. Okay, so let's see what is separating hyperplane of a convex set. The hyperplane is a relation R of order n is a flat surface of dimension n by n minus 1. So what it will do? It will do like it will separate all the convex set. It will separate the convex set and a point. Okay, in a plane. Okay, so let's see. These are all the equations, and let's see the importance. Importance is the fundamental optimization and convex analysis used in proving optimality of a condition. Important in linear programming and machine learning. Alright, so take this note. A convex set contains all line segment between its point, and a separating hyperplane divides space so that the convex set all the external point lies on opposite side, as I told you. Okay, so let's move to the next concept, and it is Fibonacci search method. So for this convex set only these definitions will come, so please see this definition, only this will come. Alright, so what is Fibonacci search method? So Fibonacci series, you will be knowing what is Fibonacci series. See, in Fibonacci series the sum of previous 2 numbers is the current number, is like sum of these 2 number, this previous 2 number is the current number. That is 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. Like this is the Fibonacci number. Okay, so it's a sequence of Fibonacci number, and Fibonacci number can be given as this. And take a note that for 1 you can write F0, for 1 you can write F1, for 2 you can write F2. So you have to give an index for that numbers. Okay, so what the task of your task is to minimize, maximize f of x over x that belongs to A to B. Okay, so algorithm will be asked in question paper. So just see and have a look over there. Divide the initial interval AB equally into Fn subinterval, and has the length of each subinterval can be given as, if you divide this A and B, see A and B is the range, so this A and B you have to divide such that the length of each interval, subinterval, comes as 1 upon F1 B minus A. Alright, so length of one divide can be calculated as ln equals to 1 upon Fn B minus A. So if you rearrange it, you will get this. So this is important result you should remember. So Fibonacci method can be given also given as this. Determine the number of iteration, how much number of iteration you have to perform, that is n. Okay, so define L2. L2 is the length of this first division. Okay, is equals to Fn minus 2 L0, where L0 is equals to B minus A. That is L0 means length of all the range. Choose the 2 point x1 and x2. You have to choose 2 points only between that range, and x1 can be given as A plus L2 star, that is equals to A plus Fn minus 2 upon Fn L1. So this 2 is the formula, you just see, and later you have to compute f of x1 and f of x2 and applying unimodal principle. The process repeated again and again. So this is the step you will be following while problem solving. Okay, so just see, and you have to write the same in the examination. Okay, see, this algorithm will be asked. So let initial interval AB be given in the number of iteration be n. So set L is equals to A and right is equals to B, that is left and right, and K is equals to iteration number. So compute x1 and x2 now. How to compute this x1 and x2 points? So if to compute x1 and x2 you will be having formula, and if f of x2 is greater than f of x1, so what? You will take the x1 value and you will change the range A, and whatever the next value to this x1 you have to take that range. Okay, and if f of x2 is less than equal to f of x1, you take this x2 and take the range which is close to this x2. Okay, So you will be getting this concept better while we will solve a question. Okay, so let's see a question. Minimize f of x is equals to x square over minus 5 15 using Fibonacci search method. Take n is equals to 7. So n is equals to 7 means f of n, that is equals to f of 7. Okay, so Fibonacci sequence can be given as this. You have to index it, okay, as I told you. So minus 5 you should write here, 15 you should write here. That x1 and x2 you need to find. Okay, so what's the formula to find x1 and x2? Let's see. So x2 can be given as left plus this ratio. What is the ratio? Ratio is fn minus k upon fn minus k plus 1. Let's see this first. N can be given as 7. So f7 minus k value is 1 for first iteration. So 7 minus 1 is 6. So f6 upon f of n, that is 7 minus 1 plus 1, that is equals to f6. So 7 by 6. What you will get? 7 by 6. 7 by 6 you can get as 6 by 7. 6 by 7 you can get as 13 by 21. Okay, so 13 by 21 is the ratio. You have to put 13 by 21. Okay, so L plus 13 by 21 minus this length. Okay, so what is the length? R minus L. So same you have to do here. So you will get x2 as 7.3809. You have to write here. You have to make this table in the examination with this L, R, x1, x2, f of x1, f of x2 and this L by R ratio. This is only the comparison. Whatever the value is smaller here, you have to write the same. Okay, so it's in the left, you are writing here left. If it's in the right, you will write it R. Okay, so let's see. This is the ratio as you got. So this is the L. L is minus 5 and R is 15. Okay, so minus 5 and 15. x1. What is x1? For finding x1, you should find first what is x2. For x2, you have formula here. Okay, so remember this formula: L plus this ratio and into this. Okay, so L plus this ratio into this length. Okay, so it will come as 7.3809. Okay, so after finding x2, how to find x1? x1 is equal to L plus R minus x2. See, this L plus R minus this for x1. Okay, so x1 you write here. Okay, so find the function value at x1 and the function value at x2. Keep this x1 and x2 value over this function and you will get the fx1 fx2 value. Okay, so whichever value is smaller here, you take it as the position. Okay, what is the position of this smaller value? This is in left. Okay, x1 is in left, so this is in left. So you have to preserve left in the next iteration. Okay, so let's see the second step. So in this second, what will be the ratio? Ratio will be n minus k, 7 minus 2. 7 minus 2 will be 5. So 8 will be here because for 5 8 is here. Now 7 minus 2 plus 1. 7 minus 2 is 5 plus 1 is 6. So 6. So 8 by 13. 8 by 13 is right here. Okay, so left is here. So you have to preserve this left value. Okay, so left value is minus 5. You have to preserve this left value. Okay, now you have to calculate for this right. What is right? You just don't have to do anything. You have here the right. Okay, this is left here. This is right here. Okay, if you are preserving this left value, you should take this right value, which is x2, and put it here. Okay, in right. Okay, and see, if you are preserving left value, you should pick this left value and keep it into the right x2. Okay, so you just interchange this x2 with this r and this x1 with this x2. Okay, and since you are preserving this L, same for this function value also, you should move it to the right. Okay, see, you have to move this x2 to the right and x1 to the x2 value and this function value to the fx2. Okay, so this much changes you have to do. See, it has a pattern, so notice that pattern and change it accordingly. Okay, so now you are getting the value of minus 5, 7.3809. all right, and also x2. If you get the value of x2, then L plus R minus x2 if you do, you will get the value of x1. So if you get the value of x1 and x2, you can get the value of fx1 and fx2 also. So getting the value of fx1 and fx2, you will see which number is smaller. Okay, so 0.0567 is smaller, so you should have to preserve the left value because it is in left. Okay, the left value you have to preserve. So ratio you can find, or one is a trick to find ratio is you have to subtract this. Okay, if you subtract this, you will get 21 minus 13 is what? 21 minus 13 is 8. 8 by this upper value 13. 13 minus 8 is 5 by upper value 8. 8 minus 5 by 3 by this upper value 5. Okay, like this you find the pattern right here. No, we need to again and again put the value of 7 and all. You just find the pattern. Okay, now you preserve the value of L here, left. So you have to write the value of left the same, and like that only you have to shift this right one to this right. Okay, this left one to this right value x2, x1 to the x2, fx1 to the fx2. Okay, this fx1 to this fx2. Okay, so similarly how you can calculate L plus R minus R2 as x1. This is the value of x1. How you can find L plus R minus x2? Okay, so once you get the value of x1 and x2, you can get the value of fx1 and fx2 also. Get the value and see which is smaller. So here this right one is smaller, so you have to preserve the right one. So for next step you will be preserving the right one. So see here right one is written. If you preserve the right value, you have to take this left value and put it to this left. Okay, see this is left for x1 and x2, this is left and this is right. So if you are preserving left value, you should take this right value and put it to the right. If you are preserving right value, you should take this left value and keep it to the left. Like this you are taking here to here. Okay, so all these steps you have to do the same only. If you are preserving right, then take this right value and keep it here. Take this right value and keep it here. Okay, I hope you understand. It's just simple thing. Okay, so if you are getting the value of x1 here, so how to calculate this x2? X2 again you can calculate with this formula only. L plus this ratio into R minus L. With this formula you can calculate this x2, and after calculating x1 and x2, find this fx1 fx2 and put the value which is smaller. That is left one is smaller, so left one is, you have to do till 7 iteration because take n is equals to 7, so you have to do till 7 iteration. Okay, see 7 till 7 it is taken, and after this you will conclude this x minimum, the range you will get, this range you have to conclude over here. So x minimum belongs to this range, these two range. Okay, and you have to calculate the value for this. Okay, how to calculate? See, you have to take the average. X star is equals to take this one and this one divided by 2. So this you will get. Okay, so same you have to write here also. X star dash is equal to 0.564. 564 you will be getting. I think some mistake is there. It should be this value. Okay, yeah, it should be this only. Okay, just go with this value. Alright, I hope you understand. Now let's see the second question. Minimize fx is equals to x minus 1.5. In the same question it is, but it is written in some different form. As I told you to remember a relation over here, so that relation will be using here only. Okay, so let's see. It is given in this range within the interval of uncertainty 0.25 of the initial interval of the uncertainty. Take the initial interval of uncertainty as ln, that is interval of uncertainty. Within, what within means, that is less than or equal to of uncertainty 0.25 of the initial interval. So 0.25, that is 0.25, whatever here it is written, 0.25 of initial interval, that is L naught. Okay, so like this you derive this equation, and then ln by L naught is less than equal to 0.25, and then apply the same thing. Since ln by L naught is equals to 1 by fn, so fn you will get greater than equal to 4. Now you have to iterate till 4. Okay, So apply the same things and go till 4. Okay, and I hope you understood this concept, and do like that whatever I had told you. If you are preserving L, you have to take this right value and keep it to this right value to this right, and all the left value to the left. Okay, so like that you understand this concept. Okay, so let's move to the last topic of this chapter, that is sequential search, 3-point search. Okay, so algorithm you need to see, objective function is to be maximized here inside 3 equally spaced points. See the range it is given, you have to insert 3 points in between that range. How to insert? You have to divide this with 4. Okay, so a plus b by 4, you will get 3 equally spaced points. Okay, so calculate fx0, fx1, fx2, fx3 and fx4. If the maximum value appears at any point, then take the second maximum value and take the negative. Okay, if the value that is close to the given value in the question, then no need to iterate further. That will be the stopping position and that will be your answer. Okay, so let's see. Use 3-point search interval method to find the maximum f of x is equals to x times 5 pi minus x on this interval with e value as 0.1. So what this e value is useful for? So let us see that this value only we have to see whether it is closed or not. Okay, so let's see this interval 0 to 20. Okay, so 0 here, 20 here, a is 0, b is 20. Okay, so 20 minus 0 by 4 equal to 5. So you have to divide 3 intervals by the length of 5. Okay, so 0 plus 5 is 5, 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20. Okay, so calculate all the function value at 0, 5, 10, 15, 20. You will calculate the function values. Okay, so after calculating the function value, write on this line, and you will see here as the maximum point. What is the maximum point? Maximum point here it is 57.08. 57.08 at x is equals to 10. Okay, so x1 is equals to 10, you will get 57.08. and what the second largest point, second maximum point is this one, 53.54. so you have to subtract this 57.08 with 53.54. okay, you have to subtract, it's not done here I guess, so you have to subtract it. Okay, you have to subtract and see whether if it is near to this point. If it is near to the point, you have to stop, otherwise you have to iterate one more time. Okay, so let's see. Iteration 1 can be given as, see in this interval, see the closest interval 5 and 15 is the closest interval, so this will be the next iteration interval. Okay, that is 5, 15. Okay, so 5, 15 take this, and 15 minus 5 is 10, 10 divided by 4. So you will again dividing it into 3 equal parts. Okay, so what the part will be size 2.5. So 5 plus 2.5 is 7.5, 7.5 plus 2.5 is 10, 10 plus 2.5 is 12.5, 12.5, 2.5 is 15. Okay, like that only you have to do, and find all the function values at this point and see whether which value is maximum. So at x3 61.56 you will get. Okay, so this is maximum. Okay, see the second maximum point. Second maximum point is 57.08. Now you see here, it's done here. Okay, so 61.56 minus 57.08, you will get it as 4.48, which is not close to epsilon naught. So you will do next iteration. Okay, after doing next iteration, what you will get? Divide interval into 4 equal parts. Since the interval you will get here is 5 and 10, closed interval to this maximum point. Okay, so 5 and 10. All right, so 5 and 10 you will get. Now divide again it with the 3 points. Okay, so same you have to do. 10 minus 5 is 5 by 4. Okay, 1.25. Add 1.25 here. Add 1.25. Equal interval you will get. Okay, so put all the function value here also. Okay, so see the 61.5x is maximum and the second maximum is 60.88. do the subtract it. Okay, 61.56 minus 60.88. If you do subtract it, you will get 0.68. That is not close to again epsilon value which is given in the question. Now iterate one more time with the same thing. See the maximum here you will get as 61.56 in between what 6.25 and 8.75. Take 6.25 and 8.75 as the outer range and calculate the 3 equal points in between. Okay, so like that you have to do. Now again calculate the function values. See which is greater. 61.56 is greater. Second greater is 61.61. And now do subtract it. You will get 0.05, which is close to this epsilon value. So you will terminate here, and the hence maximum value will be 61.61. Okay, sorry, this 61.61 is the maximum. Okay, 61.61 is the maximum at x equals to 8. All right. So same, this question is also the same. By using 3-point search method, find the maximum f of x is equals to, this equation is given over 3. Carry out 5 iterations. So you have to carry out 5 iterations. You don't see this by taking this negative. Okay, you don't have to see this again and again because it's written in the question. You have to take 5 iterations. So you have to take. Okay, so just do the same and take 5 iterations. You will get the answer over here. Okay, so I hope this topic is also clear to you, and with this module also ends, and I hope you understood all the words. So with this we'll meet in the next module. Okay, so bye bye.